Hello everyone, and in this video we're going to be going through paper 1 from 2024 in June. So let's get straight into it. Okay, so question 1 from Edexcel A-level, that is. Question 1, it says g of x is equal to 3x cubed minus 20x squared plus k plus 17 times x plus k, where k is a constant. Given that x minus 3 is a factor of g of x, find the value of k. So if it's the case that x minus 3 is a factor, then that means that g of 3 is going to equal 0. Okay, so what we need to do here is we need to evaluate what g of 3 is and set that equal to 0. So first of all, g of 3 is going to be 3 times by 3 cubed minus 20 times by 3 squared plus 3 times k add 17 plus k. And we work that out, that turns out to be 81 minus 180 plus 3k plus 51 plus k equals 0. Collecting like terms gives us 4k minus 48 equals 0. So then we add 48 to both sides and then finally divide by 4. And that gives us that k is equal to 12. So k is 12 is the answer to our first question on this paper. Let's have a look at question 2. Okay, question 2, it says find in ascending powers of x the first 4 terms of the binomial expansion of 1 minus 9x to the power of a half, giving each term in its simplest form. Now the first thing I would note here is that we're talking about the year 13 version of the binomial expansion because we've got a power of a half. Okay, so this is the version here that we're talking about of the binomial expansion. So let's have a look at this question. I'm just going to fold this over a little bit so we can see this here. Okay, so we're going to use this formula to help us expand. Okay, so what have we got? We have got 1. Now, by the way, first of all, I've written it as 1 plus minus 9x all to the power of a half. Okay, so I've changed it so it follows the format of 1 plus something. And what have we got? We have got here, we've got 1 plus n times x. So 1 plus our n, which is a half, times by our x, which is minus 9x. So that's 1 plus nx for the first one. And then we've got plus n times by n minus 1 over 2 times 1 times x squared. So our n is a half, and our n minus 1 is going to be a half minus 1, which is going to be minus a half. So a half minus 1 is minus a half over 2 times 1, and then we've got minus 9x squared there. And then the next term is going to be n times n minus 1 times n minus 2, which is going to be a half times by minus a half times by minus 3 over 2, all over 3 times 2 times 1. And this time that's going to be minus 9x cubed. So there's our first 4 terms as requested in this question. Okay, so now all we need to do is just literally simplify what those first 4 terms are. So we've got minus 9x over 2, and then this is going to be a half times a half is a quarter, divided by 2 it's going to be an eighth, and minus 9x squared is going to be 81x squared. Here we're going to have a half times by minus a half times by minus 3 over 2, which is going to be minus 3 over 8, and that's going to be times by 6. So that's going to be actually positive 3 over 8 times by 6. So that's going to be 3 over 48. Times by minus 9 cubed is minus 729 and x cubed. So we collect the like terms, and that's our expansion there for the binomial. So that's the first part there, A of question 2. We get 1 minus 9 over 2x minus 81 over 8x squared minus 729 over 16x cubed. Okay, now it says part B, give a reason why x is equal to minus 2 over 9 should not be used in the expansion to find an approximation for root 3. Well, I think the key point here is that this expansion is valid for the modulus of minus 9x is equal to 1. Okay, so therefore that means we can divide both sides by 9, and that means it's valid for this. The modulus of x is less than a ninth, which can be written as less than a ninth but greater than minus a ninth. Okay, so this is the range of values for which this expansion is valid, and we can see that x is equal to minus 2 over 9 is outside of that range. So it's not a valid value of x to use in that particular question. So that's why we wouldn't use it. Okay, let's see what our next question is going to be. We've got a numerical methods question here now. So for our next question, it says, given that the equation f of x is equal to 0 has a single root alpha, show that alpha lies in the interval between 3.6 and 3.7. Okay, so what we've got to do is we're looking for there to be a change of sign. Okay, so if we've got a root in some particular interval, then it needs to go either from negative to positive or vice versa. Okay, so we're going to be looking for a change of sign. So f of 3.6 turns out to be minus 0.686, and f of 3.7 turns out to be 0.211. So we've gone from negative to positive. The curve is continuous because tan is continuous in this particular interval, and x add tan x is continuous. So we now write down our sentence. We say there is a change of sign and the function is continuous. Therefore, alpha lies in that interval from 3.6 to 3.7. By the way, this notation here, it just means that x is less than or equal to 3.7, but greater than or equal to 3.6. That's what that notation there means. So that's part A done for 2 marks. Part B, find out f dashed of x. So we need to differentiate it. So x is going to differentiate into 1. Tan is going to differentiate into sec squared. But we've got sec squared of a half x. So we're going to be using the chain rule. Okay, so the tan goes to sec squared, and then the half x goes to a half. Because we differentiate the outer function, tan goes to sec squared, and we multiply it by the derivative of the inner function. So f dashed of x is 1 add a half sec squared 1 half x. And that's part B done. Part C, it says, using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha, giving your answer to 3 decimal places. So we're going to, again, the good fortunate thing here is we're given this formula in the formula booklet, which is super useful. So here we are in the formula booklet, and you can see we're given the Newton-Raphson method formula. Xn add 1 equals xn minus f dashed of xn over f dashed of xn. So we're just going to write that formula down. So in this case, that means that the x2 is going to be x1 minus f of x1 over f dashed of x1. So we can just sub in the results that we had previously now. So our x1 was 3.7, and then f of 3.7 is 3.7 add tan of a half times 3.7, and then our f dashed of x with 3.7 in would be 1 add a half sec squared times a half times 3.7. And we put all of that in, and that gives us 3.672, correct to 3 decimal places. Okay, so that's our question 3 on this paper, a nice little Newton-Raphson numerical methods question. Now question 4. We have got first principles. So we've got, given that y equals x squared, use differentiation from first principles to show that dy by dx is equal to 2x. And once again, we're talking about something that is given in the formula booklet. So we have in the formula booklet for Edexcel the first principles formula, which is that f dashed of x is the limit as h tends to 0 of f of x add h minus f of x over h. So the good news is we're given that in the formula booklet, and we don't need to remember that. So all I've done is start off by writing down that statement directly from the formula booklet. Now we just sub in the result that we have. So we have, in this case, y is equal to x squared. So that is x add h all squared minus x squared all over h. So we've just replaced, that is x add h squared, and that is our x squared, just subbing into this formula, f of x add h, and remember f of x is x squared. So now we expand this. giving us x squared add 2xh plus h squared minus x squared all over h. The x squareds cancel. This can now break down into 2xh over h and h squared over h. The h's cancel here, leaving us with 2x plus h. Now, we've got the limit as h tends to 0. And as h tends to 0, 2x add h is going to tend towards 2x. So therefore, the derivative dy by dx is equal to 2x. And that's that first principles differentiation done there. So quite a nice little question there. Okay, I hope that you found that video helpful. I'll continue this paper walkthrough in the next video.